Hey everyone, Adam Infinity here, and welcome back to Singularity Today. Today, we're diving into the world of cutting edge research in artificial intelligence. Get ready to explore exciting new advancements in 3D modeling, language models, and even the future of information retrieval. We'll be taking a closer look at some incredible research papers that are pushing the boundaries of what's possible with AI. So buckle up and get ready to have your mind blown by the incredible potential of this rapidly evolving field. In the research titled SAM 2-Point Segment Any 3DA's Videos in Zero, Shot and Promptable Manners, the researchers introduce a way to adapt a powerful image segmentation model called SAM2 for segmenting objects in three-dimensional 3D data. Think of it like having a tool that lets you select and isolate different parts of a 3D scene, like individual objects or areas within a room. What makes this research interesting is that it works without needing to train a new model specifically for 3D data. Instead, they cleverly treat the 3D data as a series of videos taken from different angles, allowing the existing SAM2 to segment the 3D space. This approach allows for flexible segmentation using various prompts like points, boxes, or even masks. The research shows that this method works well across different 3D datasets, meaning it can be applied to various scenarios like 3D objects, indoor scenes, outdoor environments, and even point cloud data from LiDAR. The researchers believe this is a significant step towards making 3D segmentation more accessible and flexible. Potential use cases include applications in autonomous driving, robotics, virtual reality, and more. Imagine using this technology to create detailed 3D models of real-world environments or to identify specific objects within complex scenes. This research is exciting because it opens up possibilities for more efficient and versatile ways to work with 3D data. In the research titled ReconX, Reconstruct Any Scene from Sparse Views with Video Diffusion Model, the authors tackle the challenge of reconstructing detailed 3D scenes from limited input images. Think of it like trying to build a 3D model of a room using only a few snapshots. It's a tough problem, as there's not enough information to fill in the gaps accurately. The authors propose a clever solution called ReconX, which leverages the power of video diffusion models. These models are trained on tons of videos and are really good at generating realistic video sequences. ReconX uses this power to create a virtual video of the scene, even with limited input. The authors overcome the challenge of maintaining consistent 3D views in the generated video by first creating a 3D point cloud of the scene, acting as a guide for the video generation process. This leads to more coherent and realistic reconstructions. The research concludes that ReconX significantly outperforms other methods in terms of quality and ability to work with different scenes. This has the potential to revolutionize how we create 3D models, particularly in areas like virtual reality, architecture, and game development, where generating realistic 3D scenes from limited data is crucial. In the research titled A Score-Based Density Formula with Applications in Diffusion Generative Models, the authors delve into the theoretical underpinnings of score-based generative models, SGEMs, specifically diffusion probabilistic models, DTMs. SGEMs have become popular due to their ability to generate incredibly realistic and diverse data. The research seeks to understand why optimizing the elbow, evidence lower bound, on the log likelihood is a successful approach for training DTMs. The authors develop a new formula that expresses the density of a continuous time diffusion process, which is the core of DDPMs. This formula shows the connection between the desired data distribution and the score function of the diffusion process. The key takeaway is that the elbow minimization effectively coincides with the true objective, providing a strong theoretical justification for using the elbow in DDPM training. The research also sheds light on the role of score matching in generative adversarial networks, GANs, and provides insights into diffusion classifiers and the recently proposed diffusion loss. This work contributes to a deeper understanding of SHIMs and their applications, enabling further advancements in generating realistic and diverse data in various domains like image generation, natural language processing, and audio synthesis. In the research titled Dissecting Out of Distribution Detection and Open Set Recognition, a critical analysis of methods and benchmarks, the authors delve into the realm of making machine learning models more robust to unexpected data. Imagine training your dog to recognize different types of food, apples, oranges, and bananas. But what happens when you give it a pineapple, which it's never seen before? That's kind of what this research explores, how to make machines handle unknown data. The research digs into two main areas: out of distribution detection, which is like having the dog bark at the pineapple, saying, "Hey, this is different," and open set recognition, which is more like having the dog say, "This is something new, but I can't tell what it is." The authors compared existing methods, proposing a new and more challenging benchmark, and surprisingly found that the method which performed best on smaller datasets didn't hold up as well on their new benchmark. They also found methods that are sensitive to the magnitude of the data features, think how big or small a feature is, tend to work well. This research is significant because it could lead to safer, more reliable machine learning models that can better handle unexpected data. Imagine self-driving cars that can identify not only traffic lights, but also unfamiliar objects on the road, or medical devices that can flag potential issues even if they haven't encountered them before. That's the kind of impact this research could have. In the research titled Assessing Large Language Models for Online Extremism Research, Identification, Explanation, and New Knowledge, the researchers explored the potential of using large language models like BERT and GPT to detect and classify extremist content online. They tested the models on social media posts containing keywords associated with far-right and far-left ideologies. The researchers found that GPT models, particularly GPT-4, performed better than BERT models in identifying extremist content, especially when provided with detailed prompts. The research also revealed that different versions of GPT exhibit unique sensitivities towards what they consider extremist, with GPT 3.5 being better at classifying far-left extremist posts and GPT-4 excelling in identifying far-right extremist posts. This research highlights the promising potential of large language models for detecting and classifying online extremism, potentially leading to the development of more efficient and effective tools for identifying extremist content online. Imagine having a tool that can quickly and accurately identify extremist posts on social media, helping to mitigate the spread of harmful ideologies. This research could contribute to the development of such tools, potentially impacting online safety and combating the spread of extremism. In the research titled Smaller, Weaker, Yet Better, Training LLM Reasoners via Compute-Optimal Sampling, the authors investigate the efficiency of using strong language models, ELMs, to generate synthetic data for training other ELMs. They find that, while using a strong model for data generation might seem intuitive, it may not be the most efficient approach. Instead, using a weaker but cheaper model for data generation can be more beneficial, leading to better reasoning abilities in the trained model. This is because weaker models tend to generate more diverse and comprehensive data, even though they may also introduce more errors. This finding challenges the current practice of solely relying on strong models for synthetic data generation, suggesting that a cost-effective approach using weaker models can be just as effective, if not more so. This research has implications for various applications involving ELMs, particularly in areas like question answering, summarization, and text generation, where effective reasoning is crucial. By optimizing the training process using this cost-effective approach, we can potentially train better reasoning ELMs with less computational resources. In the research titled Mini Omni, Language Models Can Hear, Talk While Thinking in Streaming, the authors introduce a new audio-based conversational model called Mini Omni. This model can understand and respond to spoken language in real time without relying on separate text-to-speech systems. This means that Mini Omni can hold natural, flowing conversations, much like a human would. The research team achieved this by developing a new technique for generating speech directly from text instructions. They also designed a method to improve the speed of Mini Omni's responses by using parallel processing during inference. The authors believe that their work paves the way for more natural and seamless interactions between humans and computers. Imagine having a conversation with your smartphone or smart speaker that feels as natural and conversational as talking to a friend. This research could have a significant impact on the development of virtual assistants, chatbots, and other voice control systems. It could also lead to new applications in areas like education, healthcare, and entertainment. In the research titled A Great Architecture for Edge-Based Graph Problems like TSP, the authors introduce a new kind of neural network called Great Graph Edge Attention Network to solve tricky graph problems like the traveling salesman problem, TEP. The SP is a classic problem where you need to find the shortest route that visits all cities exactly once and then returns to the starting city. The issue is that existing graph neural networks aren't great at dealing with complex routing problems where you have lots of potential connections between cities. Plus, they don't work well with real-world problems where you might not have nice straight lines between cities. GREAT is a new approach that focuses on the edges, the connections between cities, and can handle messy real-world scenarios. The research shows that GREAT can actually identify the most important edges in the TSP problem, which makes solving it much faster and easier. This allows them to create a much simpler version of the TSP by eliminating unimportant connections. The research also shows that GREAT can be combined with reinforcement learning to solve different versions of TSP, even when the distances between cities aren't symmetric. The results of this research are very promising and could have a big impact on solving many real-world problems, like finding the best routes for delivery trucks, optimizing travel plans, or even planning complex network connections. The new approach is like having a super smart assistant that helps you to focus on the most important connections, making complex problems much easier to solve. In the research titled Gina Colberg of D2, a general-purpose multilingual late interaction retriever, the authors focus on improving Colbert, a well-known model for information retrieval. Colbert uses a special method called late interaction scorings that mimics the way cross-encoders analyze text. The new version, Gina Colbert V2 incorporates some smart techniques from other models, especially those designed for handling different languages. It shows impressive results in both English and multilingual retrieval tasks, all while using less storage space than before. This means that you can retrieve information more efficiently and effectively, whether you're searching in a single language or across multiple languages. The research has the potential to significantly impact information retrieval systems, making them faster, more accurate, and more adaptable to diverse language needs. Imagine using a search engine that understands different languages and gives you precisely what you need, or having a chatbot that can seamlessly converse in various languages. These are just a few of the many use cases that could benefit from this research. In the research titled Entropic Distribution Matching and Supervised Fine-Tuning of ELMs, Less Overfitting and Better Diversity, researchers tackled the issue of large language models, ELMs, becoming too specialized and losing diversity in their responses when trained with standard methods. The usual way to fine-tune these models is using a method called cross-entropy CE loss, but it can cause the model to overfit the training data, leading to less diverse and sometimes inaccurate responses. To combat this, the research introduces a new approach called Generative Entropic Matching, which uses a technique called maximum entropy principle to encourage the model to learn a more generalized and diverse representation of the data. This approach results in ELMs that are less prone to overfitting, producing more diverse and accurate responses, especially in domains like math, reasoning, and code generation. This research has the potential to improve the performance of ELMs across various tasks, especially those that require creative and diverse output, like writing stories or generating different solutions to a problem. All right, folks, that's a wrap on today's AI Deep Dive. I hope you enjoyed this whirlwind tour of some mind-blowing research. Remember, all this was brought to you by the power of artificial intelligence, so you can rest easy knowing your human brain didn't have to do any heavy lifting. If you found this video enlightening or even mildly entertaining, please give it a thumbs up, subscribe to the channel, and leave a comment below. And be sure to check out the research papers themselves for a more in-depth look. Until next time, keep your eyes on the singularity.